time, 12 o'clock Norway time.
It's lunchtime. Is it all right if I have lunch?
As long as it's not crisps, they can wreak havoc with microphones. Welcome one and all. It's so good to have you along. Chris and I are secretly loving that this has turned out to be a very intimate gathering of 24 of us at the moment. You're all very, very welcome. We had about 150 check into our last webinar last week, which sort of crashed the system and meant not everybody could get in. So if you are trying for the second time in 2 weeks to drop in, thank you so much for your patience. And it's so good to see you and for us to get some physics teaching company. To break the ice a little bit, although to an extent Chris and I have been ad-libbing now for about 10 minutes, I'd love for you all to try and find your hands up tool. You can find this, I can find it in the panelists section or the attendees section. If you can raise your hand and just show me that you know what you're doing there. We just want to find out what you want from the session. So again, I find this under participants. Great. So seeing about half of you get those hands up. So firstly, a nice easy one to kick off with. Hands up if you are an IB physics teacher. This really is just a test of whether everybody can find the little blue hand. Okay. And hands up if you are a physics teacher not in an IB school. I'm curious because I've put a little note about this webinar on my LinkedIn, and I'm just curious if we've got any non-IB teachers here. A few. Okay, you're very welcome. Hopefully there'll be something here for you as well. Who's in their first year or two of IB physics teaching? Hands up if you're in year 1 or year 2 of IB physics teaching. So about 5 of you. Well done to you. It's a particularly stressful year for all of us with the changes to the exam system. So don't blame your head of department or IB coordinator if they haven't been quite clear as you would normally hope from your managers at school. It's been a tough year. And
I noticed Thomas Dindorf didn't put his hand up then because he's been teaching almost as long as I have. In fact, probably longer.
Maybe we can he can come on as a VIP guest speaker someday, Chris.
Yeah.
And who is here because they are a novice at distance teaching and learning? I'll put my own hand up here. That's definitely true for me. Okay, great. Looks like you've all signed up to the right webinar. Fantastic. And I just now want to check through a couple of things. Out of the following things, so everyday teaching and learning, the IA, extended essays, group 4. I'll run through each of those one more time, and I wonder if you could put your hand up if you think that that is something you'd love us to take some questions on today. So firstly, everyday teaching and learning. Who'd like ideas for doing that at a distance? Okay, well over half the room. Thank you very much. Who is here because they want to find out about the investigation from afar? You might know that Chris and I both do the investigation in year 1, so we're both in the midst of that now. Okay, a little under half, thank you. Who's here mostly for the extended essay? Okay, a few, thank you. And who's here because they are trying to plan group 4 at a distance? Okay, yes, thank you. Oh, no, sorry, a few. Chris, that was an area that I think we could have spent more time on last week, so we'll definitely take your questions on that area as well. Thank you. It's about time we introduced ourselves, and hopefully everybody who's going to join us is now in the room. So Chris, do you want to say hello?
Yeah, hi. I recognise some of the names on the list, but not everybody, so I'll just say a little bit about myself. I'm Chris Hamper. I've been teaching physics for 40 years, teaching IB for 30 years. I've been an examiner, moderator, wrote a book all that, done all that stuff. I used to be very much the teaching from the front of the class. I call myself the Lord of the Board. But 5 years ago, I got Parkinson's disease, so it sort of put a stop to all that. I had to have a new strategy. So I could have said to the students, just read my book, but I think that's a little bit of a cop out, not very active. So instead, I went for a student-centered approach, making activities for the students to do each class. The sort of thing that I'd have done years ago if I really had the time, but now I had to do it. If I didn't manage to do this, I would have to stop teaching. So I luckily I had this website with InThinking, and so I put all my material onto the website. I've been using it ever since. My students come into class, they get on with the work, they do it all themselves. I just sit at the front and wait for them to ask me questions. Sometimes they don't ask me anything. I sit there silently all class, and sometimes they ask me lots. Depends on what the topic is. So in a way, I've been distant teaching for years. The distance hasn't been very big. It's been a few meters in class, but it might as well have been sitting at home and them sitting in class. So when we isolated, when I isolated myself a couple of weeks ago, the students didn't really notice the difference. They just said it was the same as normal. They said I wasn't there, and it's been working quite well, really. I definitely prefer to be in the classroom though, rather than sitting at home. So hopefully all the activities that I produced at that time will be useful for other teachers now. Now they have to do a similar sort of thing. Yeah, that's me.
Thanks, Chris. I'm Emma. I've been teaching physics for 10 years now, and IB physics for about half of that. I got ridiculously lucky in my first year of IB teaching to attend, a bit cheekily, a category 3 course with Chris on ICT during the IA and experiments. And we got on really well, and he invited me a year later to join him on co-writing his websites, both Think IB for teachers and Study IB for students. And we got to do a couple of workshops together as well. So I'm really lucky to be here, and I know Chris is the main attraction. We've also got Ellie Wakeham in the background under the InThinking logo that you might be able to see. She's doing a wonderful job of recording this webinar, which we'll send around to everybody who registered for the session, regardless of whether they were able to drop in. So I'm now going to share my screen with you to show you where you can find a few accompanying resources and challenges for this session. Chris, perhaps you can give me the nod if I'm showing this correctly.
Yeah, it's there.
Great. So I'm just in the InThinking, thinkib.net/physics website, and I'll take you from the homepage, in fact. And I'm just in this webinar blog. Hopefully you all got directed to this in your invitation for the webinar. You can find here a video that I produced on distance learning, which was a script and ideas from both Chris and I. Hopefully you watched it before the session, but if we go at too much of a pace today, that might be where you could go to do a bit of a catch up on things like GeoGebra, Algodo, Excel, and so on. Copied JPEGs of the slides from that particular video as well. The differences between remote learning, that's very much me, doing lots of live lessons and trying frantically to maintain the everyday, and Chris's strategies of online, much more forward planning, and which enables individualized support. This, as you might know, is a bit of a repeat webinar from last week, sort of the overflow room. So I've got some unanswered questions from last session, which we'll add to today if we run out of time. I've got some links. And now, most importantly, perhaps, the InThinking Community Challenge. If you are an InThinking Physics subscriber, you'll be able to see the 23 comments that came through during last week's webinar, each of which has ideas for good distance learning strategies tried so far, what strategies you'd most like to try, and to suggest an IA that could be done at home or online. If you're a ThinkIB subscriber, please do log in right now or after the webinar, come right to this space and add to the list. We're hoping that although Chris and I are capable of coming up with a few ideas, with your brains, we might just be able to come up with 30 or 100 ideas. For those who aren't subscribers, I'll just copy these questions now into the chat. And if you do respond in the chat, we'd be very grateful. We will copy them into these comments afterwards as well. Sam, I'm sorry about the sound. I blame London. It's although they claim to have fibre here, I'm pretty sure there's some old copper wiring running up the side of my building and most others. Sorry about that. Chris, anything you'd like to say or add?
Not at the moment. Let's see what people want to, what questions people ask.
Yeah, okay. So without further ado, we will move to the Q&A rather than the chat. So if you can join us there. And I think we're pretty much okay to just throw this open. 33 of you, we've got about 20 minutes, so we may well just be able to take something from everyone. And if not, we'll certainly bundle together what we can. So Chris, our first question is coming from Roberta. How do you assess students? Do you want to talk a bit about short quizzes?
Yeah. Well, assessing students, normally I'm running every lesson. I give them a small test at the beginning, a 10 and 15-minute test, and I build up a whole load of grades based on that. But it's not so easy to do that online, so I'm not really worrying about it. I'm giving them the multiple choice quizzes online and seeing how they do in those and using that. But I think I don't want to get too hung up on testing them all the time. I think I want to see that they're engaged in the activities and they're doing something. I'm not too worried about their performance. I mean, assuming this isn't going to go on for for another year, although we don't know that. I think maybe if it's a long several months more, maybe I'll start giving them tests. But I think I'd probably do something like them photographing a quiz or something. I am making sure they're doing their work by giving them extra assignments to do. So if there's an experiment to be done, I get them to put the graph of the experiment into Google Classroom, so I can actually see that they've done it rather than just assuming they have. But when if I was in the classroom in the lab, I'd of course go around and have a look at their computers and make sure they're doing stuff. So there needs to be that sort of checkup online too.
Yeah, I mean, there's so many different types of assessment, aren't there? There's the assessment that takes place usually with our eyes and ears every second of every lesson, where we're watching the class intently as we speak or as we set work for them. And that's harder to do at the moment. And as Chris says, ThinkIB at the moment isn't really set up for that, but hopefully your school has got something like Microsoft Teams or Google Hangouts or another online conferencing tool like Zoom to enable you to check in with your class live every once in a while. And if not, like Chris, I've been asking students to submit the Excel sheet that they produce or a photograph of the questions they've been answering in the circumstances where it's not possible to set the work using multiple choice quizzes on ThinkIB. I am loving, though, all the automatic marking that ThinkIB can do. It's lovely to be able to set 5 quizzes in 5 minutes and get the responses back and analyse in that way. And I know, Chris, just not to linger too much on this one question, but I know, Chris, you're not a huge fan of doing massive end of topic tests. Chris, no, I remember.
Yeah, we do an end of year test, but not end of topic. I really want to try to encourage the students to work consistently all the time, and not just for the test. Some of the students don't like it. They say, why can't you just give us a big test at the end of the topic? and so he can revise and do well in it. But they really, in physics, they really have to work all the time, and so they understand each topic, what's come before each topic. So yeah, I try to stick with not too many long tests.
I'll pick up on Sam's point here. Sam's actually done something quite innovative. I've not heard of this before, where he's actually watched his class do a written test with their cameras on. Some people did worse than expected, even cheated. I've not heard of that before. I have to say, at my school, despite being a South London school with South London teenagers, we have been just trusting our students to do the work without undue assistance. But actually, Chris, I tend to do a lot of my tests open book. How do you feel about that?
Yeah. I think it's fine. In Norway, they have these long exams where it's all open book. So I think and the universities, I think, are moving more to that as well, rather than and then getting questions that would be very difficult to cheat with. So, but, I see there's quite a few questions about IA coming up. I've just finished my IA with my first year class, and they started when they were in the class, and they finished off at home, and it did work really well because it gave them, it was a very clear thing they had to do, very clear aims. They knew what they had to do, and they did it in their own time. I had some really interesting ones where they were using an oven to heat up cores of wire, using lots of batteries in a line instead of using a voltmeter. I had to give them a lot of support online, and so but it was, in a way, it was easier to give them support online than in the class. So it worked pretty well. There was one student where I had to do the experiment for in class, so I had to wind a handle on a mechanical energy to heat apparatus.
And Chris, I know you're a huge proponent of doing the IA in year one. Can we perhaps answer again and explain why that is?
There's several reasons. One of them is because there's so many IAs happen in the second year, they get bogged down with it. Also, it's before the summer holiday is better than after summer holiday. After summer holiday, they've forgotten how to use Logger Pro and Excel and everything. You have to start again. We have quite a long summer holiday. And so I think it's better to get them at the end of the first year whilst they're still keen. They remember everything about all the skills they've learned, so it works really well. Also means in the second year you can relax a bit on the error bars and all this business, and you do the experiments more for reinforcing theory rather than for practice for the IA. So it gives you a bit of freedom in the second year. So I think it works really well. Some of the students have to struggle a bit because they choose topics that they haven't studied yet, but most of the topics are sort of mechanics. It sort of works okay.
Yeah, it's always worth doing electricity and some waves as well as mechanics before you introduce the IA. But once you've done those topics, you're good to go. Chris also takes the time to allow his students to do a sort of no stress mini IA, which is a page that's currently free on our website. Chris, do you want to say a little about your bow and arrow IA?
Yeah, the sort of bow and arrow thing's a good example of something you can do. Many possible research questions, many variables. It's a simple bow made out of a piece of a plastic carton, an ice cream carton, and an arrow made, which is a straw. And they can take measurements with a ruler. Video analysis is obviously a really good way of measuring things. I think it doesn't really matter that the errors come out to be quite big. I actually had one of my students thought a good way of measuring where the arrow lands was to paint it with paint. And I came into the lab one morning and the floor was covered in yellow paint. So that didn't go down too well. It'll probably go down even worse at home. But yeah, I think there are many possible things you can do at home. One of my students was going to measure the pressure in a football against the height of bounce, which is one of those sort of a bit boring but safe options. And he didn't have a pressure meter back at home in Senegal, so instead we thought, well, he can sit on the ball and see how far it squashes. and then try that. I think, Thomas, you mentioned electroscope. Yeah, I've had a student making an electroscope out of an old light bulb and some tin foil. I think in terms of personal engagement, although unfortunately it's only 2 marks, they have great possibility for personal engagement when making their own apparatus at home. So it works really well. And also great possibility for saying, how would you improve this apparatus? Because their apparatus are often pretty poor.
Yeah, I've got one of my students at the moment who's he's building a sort of a seesaw out of a glue stick, an elastic band, and some sort of small plank. And he's got a measuring jug, even though he doesn't have a set of kitchen scales, and he's pouring different amounts of water into a bottle to drop to create different forces on different coins. I don't think he's quite got a focused question yet, but I'm delighted to see that he's using the known densities that he's got access to. And of course, you can always look up the mass of a coin online. I'm pleasantly surprised. But Sam, on your point about Logger Pro, I feel you. I'm sad to have lost our school-based access to Logger Pro as well. So I'm frantically learning how to use Tracker, in which you can upload any video for free. I don't know if it does all of the error analysis stuff that I used to love with Logger Pro.
You can, with Logger Pro license, you can give it to all your students on their own computers as well. Included. And this is a question about the first draft and final draft in year 1. I did the whole thing in 3 or 4 weeks, from first draft to final draft. And I think it's very important to get that final draft from the students and say, that's it, it's finished, done, forget it. So some of my colleagues, they spend months and months doing this process, and the students just seem to never end. So when I say I do it in year 1, I do the whole thing.
We do as well. I set, as IB coordinator, a reasonably strict schedule for the IAs at my school, because otherwise, with the UK university system being so concentrated in September and October, things just get way too on top of the students. So we make a commitment in science to having ours wrapped up summer.
When I do the IA, I just do the IA. And I think that's very important when you're doing it at a distance, because students have difficulty managing their time. Whether it's in class or at home, they only do the IA. Every class in those 3 weeks is for doing IA. And so I say to them, you've got no excuse, you've got 10 hours of class time, you can use that, and you can actually do it all in class time. I actually found that I had to do a lot of one-to-one chats with the students. We're using Google Hangouts. And I now discover that maybe that's not allowed. So which would really mess up my whole strategy, because you can't do IA advice to a whole class.
As part of my online launch I did of our IA, I booked an hour with my students when I knew they didn't have class, and I talked through everything that I would normally have done in the room, from the criteria to the expectations to exemplar ideas, and they seem to get on really well, and so far the ideas that are coming in are looking good.
So I was asking about class sizes, a bit embarrassing there. I've got very small classes. I opt to have, I actually teach all the blocks in the timetable, so I have more teaching hours than any other teacher in the school. But I have small classes instead, because I find it much easier, especially doing a student-centered approach. Some of my classes are a bit too small, like 5, but they're between 5 and 12, I think is my biggest class. But I have 6 classes.
Perhaps we can take Sam and Million's questions on feedback during the IA. Miljan in particular has asked, how do we give feedback in such a short time on the first draft? I think Chris and I both would really encourage you to engage with your students much more than just waiting until they've done what they think is a finished first draft, because there's a huge risk that they could come up with a question that's unanswerable, or that or variables that don't have any kind of theory linking them.
Yeah, I'm using Google Classroom for that, and so I'm actually get a bit obsessed by it, and looking at what they're doing almost every day, because you got to catch it before the first draft, really, as Emma said. Sometimes I think I'm looking at their work more than they are.
It also links to how we're checking for authenticity. You can get a very good sense of the rate at which a student is working through a shared document, actually at a distance than you even would if they were doing it in class time and at home, I think. Chris, there's a few people asking about the IA and the extended essay and the relationship between those. I think I'd be right in saying, and often this is what's happened to my students, they've done an IA, something that extends beyond the course, and they find that they simply can't write it up in 12 pages, and it just becomes an extended essay. Is that something that you've ever experienced?
I have about 3 or 4 this year that could just be submitted as extended essays as they are. I don't let them do it though, because then they have to do another IA. So I don't once I've got the IA in, it's over. So, but I mean, the difference really is the structure of it is a bit different, and there's much more of an emphasis on things like citations and stuff, making it look like a paper. So it's more, the E is more like a scientific paper, and the IA is more like a long practical write-up, I would say.
Take Ahmad's question right from 15 minutes ago on the difference between an IA and EE topic. How would you know, Chris, whether a topic was an IA or an EE topic?
I mean, EE should be either a topic that's not in the syllabus, or it's an extension of what they're doing in the syllabus. So it can be, whereas an IA can be something very, very much standard. As the mention of what does the IB think about students collecting data at home? I don't know, but it has to be okay. I mean, totally confident, because in fact, some students, when they're doing the normal IAs, doing them at home in some schools, they do it as homework, so it's not a problem. But you do have to. I mean, I trust my students pretty much, so I do know they're doing what they say.
On Jagruti's point about proving a hypothesis, I'm always a little wary of using the word proof, probably verify. And I think a student would be quite foolhardy to start on an investigation that hasn't got a clear hypothesis, whether that's an equation or some sort of known quantitative relationship or a value to be found, because otherwise there's no basis on which to discuss the results. So for me, yes, that's one of the things I insist on when my students embark on the investigation.
Question on what about the prescribed practicals? Most of them you can do it at home or in simulation. I mean, I'm a big fan of simulations, but simulations for showing what should happen, not replacing real experiments. But I mean, a lot of them can be done at home using a kettle for boiling water. You can measure specific capacity by just heating the kettle from 0 to 100. Not 0, 20 degrees to 100. You don't even need a thermometer if you're using those room temperature and boiling. So I think most of them can. I think we went through them, didn't we, Emma, and checked that they all could be done.
Yes, we've got a way for everything.
On the website, I think there's a real example of each and a simulated example of each. So, I mean, the main thing is, yeah, go on.
Oh, I was going to say, shall we move on to, we've said a lot about investigations and in a sense, therefore, about the extended essay. Shall we say a bit about group 4?
Yeah, I mean, we were supposed to be doing group 4 this time, but we've postponed it till they come back, because it's such a good example of where you can get a day of science with everyone working together on some fun projects. This year we were going to, my big idea was we were going to buy 100 mirrors, and have the students standing around in a big circle or in a big group, and trying to focus the sun's energy onto some water and see if we can make it hot as part of a big project on solar power. I don't want to do that online. I can't really do it online. So I think we're going to save that one till later.
We're going to save ours as well, actually, for what it's worth. It being the most wonderful part of the IB experience for many of our students, with it being something that's compulsory but unassessed, we're absolutely going to make time for it towards the end of this calendar year, and hopefully we'll be back at school by then. So many questions. Should the group 4 idea come from the students?
Not necessarily. Sometimes you can have it from the students, but I think I come up with better ideas sometimes. Sometimes they'll come up with something that just can't be done. I mean, we try to make it, a lot of ours are sort of something where there's something to be built or some goal at the end of the day, rather than being sort of too vague.
I'm conscious of time, and we will actually be wrapping up in the next few minutes. What I'd suggest is, if you've got any very individual questions, things that apply to you or your context, I'll tell you in a minute just how you can ask us those. I'm frantically reading through what's already come in, and I think we've addressed most of it, at least in part. Genwa's point, can a student get a 2 for personal engagement only if it's never been done before? No, they can get a 2 for, as long as you are convinced that they have had authentic interest and engagement in how they've done their experiment, then, and as long as their report as a whole flows from start to finish with clear continuation of the research question throughout, no, I think 2 is very achievable by anybody, even if the experiment's been done before.
Yeah, this idea that they have to think of some new physics is not really the case. I mean, they can do something fairly straightforward, but they have to have a bit of a twist on it, or they have to compare it to a simulation or compare it with another method or something. So there's very little that they could do that hasn't been done before.
I think there's most of the rest of what I'm seeing has been addressed in our video, at least to an extent. And do rest assured, everyone, we will go through any questions that haven't been answered after this session, and we'll make sure that we respond to your question in the webinar blog on our site, as you saw earlier. Chris, is there anything else you'd like to pick up on? Perhaps to agree to use very final point about simulations and modelling.
Yeah, almost all of my students use some sort of simulation or modelling in their evaluation or discussion of their experiment, and they're generally using Algodoo for doing that. For example, the student doing this one about the ball is modelling the ball, squashy ball with a box with a spring in it. And the stiffer the spring is, the less energy it absorbs from the bounce, the less the box bounces. So that certainly makes the person engagement much more easy to give a 2 for when they're actually doing something like that. In the activities I use simulations a lot, mainly GeoGebra simulations, because they're nice HTML5 applets that can be embedded, and they're for reinforcing the theory. Because to reinforce theory, a simulation will do exactly what you want it to do, whereas an actual practical sometimes doesn't do quite what you want. So in a way, to reinforce theory, I use that, but then to see how it is in reality, I'd use a practical.
Yeah, absolutely. It's so good for students to be able to do a comparison, and they learn a huge amount about physics and the nature of physics as a whole by having a go at something both in the real world with their hands and a more mathematically based representation. So I think, yeah, go ahead, Chris. I was just about to say that's our time.
Yeah, just saying, if you're going to expect the students to do these things with GeoGebra and Algodoo, you have to, of course, introduce them to it through the course beforehand. It's unreasonable to expect a student to learn how to use GeoGebra whilst doing their IA. So I give my students lots of practice and give them problems to solve where they have to build carts and model things. I also do quite a lot of iterative modeling, which is useful sometimes when they can't write an equation for a phenomenon. But that's all built into my activities that I give the students.
And maybe very, very finally, Chris, just, I know it was sort of, maybe we've come to this before, but if a student was to do something just with a model, I wouldn't use PhET because obviously PhET is designed and pre-made for you to be perfect. But if something was just to be done on, say, Algodoo, what would you do about uncertainties?
Yeah, I think uncertainties, it depends what they're doing. Sometimes you can have simulation, like for example, the gas in a box, having lots and lots of particles in the box. You're going to get a whole variation of readings for the force on the walls of that, because of the particle hitting at different times. So there would be uncertainties there. If you're looking at something like acceleration of a ball with no air resistance and the gravity of 9.8 meters per second squared, you're going to get exactly the right result. Well, not exactly, but within the errors of the programmer. So then I think when students are using simulations to model what they did in reality, I tend to forget about the uncertainties. Do your uncertainty calculation in your real thing and not in the model. But they can still talk about the uncertainties. They can talk about the fact that there really aren't any. So I mean, they can still have a consideration for the lack of uncertainties in their data. It is possible to program them in, of course, but it all becomes a bit pointless.
Yeah. Okay, well, I think I've just typed through a few more responses. So we've got a very, very small number of questions left for us to answer in the blog. Everybody who's come along, thank you so much. And thank you so much for your questions. I think we've really hit on a very special format here of 30 or so attendees with the two of us as panelists. Please stay safe, please stay well. It's been lovely to talk about teaching and learning, the investigation, bridging the gap to the extended essay, and a little bit on group 4 with you. If you subscribe to our site, you can ask us your individual questions day in, day out. You can add a comment to any of our website pages, and usually Chris will get back to you within a day or two. I think, Chris, you're on top of it.
Well, a day or two? No, a day.
An hour or two, yeah.
An hour or two.
We will make sure that everybody who signed up for this webinar gets a link to the recording and the video, the sort of flipped learning video, the challenge questions, the links that we'd recommend, and our slides are all there ready and waiting for you in the blog. So once again, my EasyJet moment, a special thank you to our ThinkIB subscribers. You know where we are, and we know where you are. Please stop in any time. And to those who don't currently subscribe to ThinkIB and you want to stay in touch, you can do now for free. You can get a trial during this hideous global pandemic, and you can see if you like us enough to subscribe full-time afterwards. Study IB is also free for students, and of course, being free, there's nothing to stop you as a teacher signing up to check it out as well. So that's it from me. Thank you all so much for coming along.
That's it from me.
Great. Thanks, guys. Thank you.
I'm going to have lunch now.
Yeah, I'll get another coffee. Thanks, Diego. Thanks, Sander. Thanks, Priya. Thank you, Lisa. Aloha. Gosh, I wonder if you're in Hawaii. Merci, Sam. Thanks,
Cheers.
Thomas.
We'll have a good lunch. See you, Thomas.
Thanks, Zoe. Thanks for coming along.
Cheers.
Bye, Harsh. Now, I'm just going to have a look through the chat to see if anything else came through. Okay. Great, Ahmad. Thank you. Hopefully the second of many. And Deli, I know you're lurking somewhere there. I'm just going to have a look through the remaining Q&A to note anything that still needs to be addressed.
Sure.
Thank you.
What about Sheena's question about the EE? And this is a very specific question.
Yes, I wonder if Sheena's still listening in. Sheena, we didn't take your question just because it was quite specific, I thought, to you. But I'll, definitely think musical instruments with Audacity are a good thing.
I think on a musical instrument would be okay, but having to design an instrument is maybe not such a good thing.
Mm.
Has to be a very specific physics question.
I don't know if Sam Edgecombe is still here. He got his worth. Lots of questions for him. Thank you, Sam.
He's regular contributor on the Facebook group.
Oh, yeah. And a response to Sam, Vernier provides a data library. Vernier graphical analysis.
Yeah.
Thank you for your response.
The questions and answers disappear after a while, do they?
Sorry?
Or the answered ones disappear?
Yeah, I was trying to make...
Click them off.
Trying to keep it clean and clear.
Okay, I see. I didn't realize you could do that.
I'll make a note of Serkan's helpful idea in the comment of the blog. Great. And point about an instrument. Great. Well, thank you so much to everybody who's still signing out. Lovely to have you along. And 7 p.m. in Bali. Well, Sita, I hope if you're still listening that you have a wonderful evening and hopefully something nice to look at. Deli, I think I've got all we need, so I think we're good to lock the door.
Okay, then we'll end the meeting.
Thanks, everyone.
Okay, thank you. Good job.
See you on Skype.
Yes. Bye.
Bye. Bye.
Bye.